review, and then we're going to dive into graphing these things. Okay, now this is the best overview. This is kind of where what I talked about in the lesson. I kind of just go over the various polynomial functions. So you've got your constant, your linear, quadratic, cubic. Okay, there's going to be a point where I go over all of the functions, and I've done the whole whiteboard like side by side, like compare them all to each other, because we're going to do more, right? And so on your study sheet, you want to have some sort of way to identify some of the properties of these functions. Okay, so we've got our constant, our linear, quadratic, cubic. If you think about it, I know I've done, I've shown you. If you wrote down the notes, if you didn't, you should still do that. Okay, you should still take the time to do that. But if you look at the very top, this looks like a cubic function, doesn't it? It has the x to the power of 3. But if I let a, b, and c be 0, all of them are 0, and all you're left with is d, you have a constant function, right? So if I were to slide d up and down, it's just a constant function, flat, right? As soon as c is in front of the x term, right? As soon as c is changed, it now becomes a linear, and it has a bit of a slant to it, a slope. Okay? Let's say I would enable b in this case. So b, right? As soon as it's a quadratic, you turn into a parabola, and guess what? D is still doing the same thing. It shifts everything up and down. That last constant here shifts everything up and down. If I then enable the a, which is in front of the x cubed, that's when you have the cubic, right? And it gets more wonky as you change the other ones. Like it does get more, how would you say it, more sharp, the sharper difference. But really a makes this cubic, right? And watch this, d will always just shift the entire graph either up or down. That's something I want you to remember. That last constant, that last value is your y-intercept. But if you were to change it either on the you increase it or you decrease it, it actually shifts. It does a vertical shift to the entire thing. Okay. So, and one more thing I want you to remember is the last one, the turning points. A constant and a linear have no turning points. It just consistently either goes up or down or stays sideways. Whereas your quadratic has one turning point, right? It will go up, 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 and then hit that maximum, and then it turns and it comes down. Or when it comes from left to right, it comes down, hits the lowest point, then goes back up. So it has one turning point no matter what. Cubic has 0 or 2. That's something important to remember. Did I say 0 or 2? Is that what you have in your notes? 0 or 2? Yes, that's right. Sorry, I was thinking x-intercepts. So turning points are all right. And this is what I mean. So right now the sun has one turning point there and another turning point right there. It has 2 turning points. But if you change b, let's see, I'm going to change it to 0. If I can do that. Oh, and there we go. See, that has no turning point. It has a little bit of a curve to it there, but it doesn't have a turning point where you like change direction going back up or then back down. Okay, that's what I mean by turning points. So that's something to remember here. And watch this. The number of x-intercepts, this one right here is very important as well. So x-intercepts, you could have 0, 1, or 2. And with cubic, you could have 1, 2, or 3. Okay, that's also important to remember. And I probably will have talked about it in the, but let me try the cubic here. Right now, this one has 1. Let's change something here. You would have 2. it's going to be hard for me to replicate. If it touches, if this were to touch just exactly on the x-axis, usually you have 1, 2. This one right now has three intercepts, right? 1, 2, and 3. Let's see if I can try to make it. You know, I'm going to be sitting here all day probably trying to get that to land right on the. Anyways, I'm not going to try. But it is possible to have 2 as well. So 1, 2, or 3. Another thing that I want you to remember or to keep in mind is go to page 6 here. Go to page 6. It looks like this. If you have an odd degree, so a degree of 1 or 3, you have similar what? End behavior. Similar end behavior. The graphs look completely different, but the end behaviors are the same. Okay? So you're either going to go, I'm going to add to this maybe, if the leading coefficient is negative, if A is negative, you're going from quadrant 2 to quadrant 4. This is on page 6. Okay, that is what's going to happen. So you're linear, you're starting here, you end up there. Your cubic, you still start in quadrant 2, and then you do some wonky stuff along the way, but you still end up in quadrant 4. I'm going to highlight the leading coefficient. If the leading coefficient is positive, I'm going to circle that, right? Circle the negative and the positive. If your leading coefficient is positive, you're going to go from quadrant 3 to quadrant 1 regardless, whether it's a linear or whether it is a cubic. You start here, you end there. So that's what we call with end behavior. So quadrant 3 to quadrant 1. Mr. Dixon, do we have to use Roman numerals? You do not have to use Roman numerals when it comes to quadrants. I'm okay with that. So odd degree have similar end behaviors, and so do even degrees, even degree functions. Even though within the scope of this unit, we don't go past, like cubic is the highest we go. So I can't really do quadratic and quartic. Quartic is like 4. But I think I did, because I just couldn't help myself, right? But this is not something I would expect you to know or about a quartic function. You would just have to say, hey, even degree functions would have a similar end behavior. That's something I would expect you to know, right? So this is A is negative. You go from quadrant 3 to 4. And when it's positive, when A is positive, you go from quadrant 2 and end up in quadrant 1. So that's kind of like your end behavior. And to be honest, this property, when it's on the exam, it's very short and sweet. It's either a multiple choice or just tell me what the end behavior is or something like that. And when we go over exams, you'll see it. You'll see this kind of stuff. Okay. All right. Let's keep going. Oh, and by the way, you should not do that because it's going to just mess everything up here. But this, you could have a quadratic that does this, right? That has a much deeper dip than this one. You still go from quadrant 2 to quadrant 1. You know what I mean? It's the end behavior that we're after. Same with all these cubic. This could be way wonkier. The cubic could do all kinds of stuff, but you would go from quadrant 3 to quadrant 1. That's what remains. Okay, let's keep going. I talked about the window. I feel like you should have seen this in grade 11 applied if you were awake during the lessons. I did talk about the window, and it's just important that you understand that the x min and the x max values govern what you see horizontally, whereas the y min and the y max govern or tell you what you're going to see vertically. Okay. It is important. I'm going to say this because it happens all the time. This has to be lower than the Y max. I hope you understand that. If you flip it, some students like just think it's just like put anything in there. If this isn't lower than that, the value you enter, it's going to complain. It's going to give you a window error or something like that. Okay. Okay. Zoom. This is very important. I'm using zoom functions more and more these days when I teach because I think it's a very useful tool. Why wouldn't we use it? So if you press the zoom button, the three main ones that I use are zoom standard, zoom stat, and zoom fit. This is probably, quite frankly, one of the ones that will kind of get you started. It won't always solve anything like the situation for you, but zoom fit is the one I use a lot. So that's zoom and then press 0 because it's the very last option on your calculator. I know I'm repeating myself. I do know that. I may have talked about this in the video, but zoom fit is right at the bottom, like it doesn't even show up at first. But I do use zoom fit, zoom stat, and zoom standard. I use that a lot too. Not to say that you can't use zoom in or zoom out. You can still use those as well. I will from time to time use those. Okay. And then recall x-intercepts is equal to the roots, which is equal to the zeros, which is solutions. So when you're asked to solve, guess what? You're asked to find the x-intercepts. Okay. Okay, here we go. Let's get started now with the graphing part. I think this is important to add to your study sheet. At least, okay, maybe not yet. I will maybe narrow it down a little bit because I don't want you to use too much real estate on your study sheet just yet. But this part here, for a graph, you need the following. This is what we would expect you to have. Every graph should include these, okay? Every graph should include these things right there. So you want to, whether I've asked you to find these before or not, you need to figure out the intercepts. That means x and y intercept, local maximums and local minimums. What is that? I'll talk about that in a bit. They're not always there. And then your graph should have a scale, labels, intercepts, min and the max, right? Should always have that included. I will say this for labels. So you would want to go time and also tell me what is time measured in. Is it in seconds? Is it minutes? Is it days? Is it what is it? Right? So you want to be specific with your labels. And let's go ahead and graph some of these here. Oh, maybe I should refresh your memory here. If you want to extract points from your calculator, you want to press second trace. And then these options are here. So we're going to use value, which determines the y value if you're given an x value. 0 can be used to find the zeros or the x-intercepts. We will not use this. I will not really use this one, to be honest. And then minimum to find a low point, a dip on the graph. Maximum to find a high point or a peak on the graph. And intersect, this will be used to determine the point of intersection between two lines. Okay, so everything but this one, I use all the other ones. And yes, it may take some time to remember how to use these. It's been a while for some of you. That's okay. We'll deal with that. So when you get an equation like this and you're asked to graph, I want you to enter that into y1. Okay, you put this into y1 right away. So let's go ahead and do that. press y equals. You want to clear everything that's there. So you just go to it, press clear. One more thing, when you're given an equation, do you remember what has to happen to the plots? They have to be turned off. So you do not want this, for example, you don't want anything highlighted. When you're entering an equation manually, make sure that's all turned off, because sometimes it gives you issues if that's turned off. So let's type this in. I always use brackets for my leading coefficient. So I go bracket negative, not minus, negative 2 divided by 3, close brackets, and you press the X button here, remember? It's next to alpha, and then you go plus 15. Before we graph, what do we know about this graph? We know that this is a linear. Why is that? Because it's just x. Right? Leading coefficient is negative 2/3. So what does that tell us? If it's negative, we know that this graph is decreasing from left to right. We know that it's going to go like this. You always go from left to right. So we already know those two things. We know that the y-intercept is going to be 15. We know that because that last constant is always going to be our y-intercept. So without much further, we already know a bunch of information about this graph we're about to make. So now let's hit graph on your calculator. I happen to see it on my screen, but it could be that you don't. Let's try zoom fit. I'm just going to try it. Zoom and then 0, or go all the way to zoom fit. It does a pretty good job. Except for it doesn't, the x-intercept is kind of cut off here. It does show your x-axis here because you have those ticks. So I want to make sure I do see it completely. So I'm going to increase my x max a little bit, which is this side here, to 20. I'm going to reduce my y min to like negative 10 or something like that. I want to be below the x-axis. That's really what I'm doing here. Everything else you don't touch. I just touch the x min, x max, y min, y max. That's all I do. Hit graph. Not bad, but I still cannot see the x-intercept. Do you see that? I still have to increase my x max. I'm going to go 30. There we go. Now we're talking. This is a pretty good graph because I see both intercepts. Okay? So we're going to say y-intercept is already taken care of. How do you find the x-intercept? Anybody remember? We got to go second. Oh no. I should know these things, right? The way I do it is I let y2 equal to 0. And then I'm going to go second, trace, intercept. That's exactly what I do. I go y2, so I go to y equals. I let y2 equal to 0. You have to hit graph at that point. And you see that it's the horizontal line that goes right along the x-axis. So if I find the intersection between those two lines, I find the x-intercept. So second, trace, intersect. I went intercept on my notes here. Intersect. And what do you get? 22.5, 0, right? Does this have a min or a max, this function? No, it doesn't have one low point and one high point. It just doesn't. No min or max on linear or constant functions. It just doesn't exist, right? So we don't worry about it. That's all we need to do with linears. And if you're thinking, what's this here, Mr. Erickson? What is that? don't worry about it. I'm trying to let you see, hey, let's make your window in such a way that you see from -20 the domain to +20, but we're not going to worry about it. I just want you to worry about making sure these things are on there, the intercepts, the local mins and max. That's what I want you to focus on. Okay, here we go. When you graph, guys, I'm helping you out with the grid, but you need to do the rest. I want you to have arrowheads along the x and y axis. I want you to label it x and y for now. Later on, it's going to be a word problem. And I want you to come up with a scale. In this case, I need to make sure that I have room to put 22.5 along the x-axis here. So I'm going to go 5. I want you to clearly tell me, this is going to be, it's not going to be perfect, but we're going to make it work. So guess what? I'm going to have to erase a little bit and just extend it a tab. And I'm looking for consistent increases by the same gap. So this would be 25, and that's my x-axis there. Okay. And I'm going to do the same thing going to the negatives. You don't have to do the whole axis. If I see a couple, I know that you're staying consistent. For my y, I need to make sure I include the 15. So I'm going to do the same scale. You may use a different scale on your y-axis, but I will just keep it the same. This is -5, -10, that's good enough. So you've labeled, you have a scale, and now all you have to do is plot these points. There's one, and then 22.5 would be right between 20 and 25. So if it's exact, I expect you to find the exact location. If it's approximate, you will see later on we're dealing with really big numbers. I won't argue with you if you're off by just a bit. Like, it's just not going to matter. If it's approximate, we're good. And we need a ruler for this one, unless you're really good at drawing straight lines, or just use your credit card if you have one, debit card. Y is equal to -2/3 x plus 15. There we go. But I want you to double check if you're doing this right. I don't want you to have a line pointing up and you just move on. You're like, I'm happy with it. Wait a minute, your leading coefficient is negative. It should be dropping from left to right. Okay? So those things are important to us in this course. This is a linear, the easiest ones, I would say. Linear functions are easier to do. Keep in mind, whatever they taught you in grade 10, Intro to Applied and Pre-Cal, is still okay, or in any other course. You could have started with your y-intercept, and what is my slope saying? Drop 2, run 3, drop 2, run 3, drop 2, run 3. That's what's happening throughout this entire line. But guess what? They're not always going to be this pretty, right? Your leading coefficient may be an ugly decimal or something like that. So I'd say the best way to do it is find your intercepts, connect them, you're good to go, right? Let's keep going. A quadratic, yes. And I made it a point to make it like I made the coefficients ugly, right? Like just nothing pretty, no whole numbers like decimals, maybe some fractions, right? So we're gonna figure this out. Enter that into your calculators, please. Oh. Yeah, we'll do that first, yeah. So you go to y equals, clear. Guess what, the y2 you can probably leave at 0 already. I'm just gonna leave it at y0. And I'm gonna go negative 0.067 x squared. And I know nowadays when you text, if you're off or if you make a mistake, it's not a big deal. But when you do these ones, please double check. It just takes a moment to double check that you didn't miss anything. Okay, so we're good. Plot 1, 2, 3, they're all off. Let's hit graph. I hope we don't see anything. Yeah, it's really bad. That's okay. This is where you come in. It's like, what do I know about this one? I know that this is a quadratic. Why? Because the highest exponent is 2. So I know this is a quadratic. The leading coefficient is equal to negative 0.067. Okay? So I know that this parabola is going to be pointing down like this. I know it. I know that my y-intercept is governed by that last value. So it's 0.80 and then 85. So guess what? My y max better be 85, if not greater. Correct? Because 85 is my y-intercept. So imagine this is your y-intercept and it cuts through there and it does something like this. Or it could be over here on this side and do something like this. We don't know yet. But it is pointing down. We know the y-intercept. So let's try zoom fit. I'm just curious. I haven't used zoom fit a whole lot in the past. I'm going to go zoom and then 0. It's a linear, Mr. Dixon. It's a linear. Look. No. You know it's a quadratic. You know it's doing this, right? It's going to go like, it's going to go like this, and it's just keep going, and it will do something like this. So what do we need to increase right now? Y max for sure, because it keeps going up. So Y max and the X max, I'm going to increase both of those. So window, what should I go with X max? I'm just going to go big or go home, right? So 200. I have a feeling it's going to go quite a bit over my Y max. What do you think? You want to play bingo? You want to give me a number? 5,000? 3,000? Let's try something, right? Don't go too big. Like, don't go 50,000, because now all of a sudden you just see a little blimp, like, right? Like, it's too much. I'm way off. Kind of like where this is going, right? So X max is not bad, but the Y max needs to increase significantly. So I'm going to go to Y max, and I'm going to go 4 times 5,000. So I'm going to go 20,000. Try it again. Overkill, right? It's overkill. But that's okay. I'm going to investigate further. I'm going to increase my X max. Let's keep increasing our X max. I'm going to go 1,000 there. There we go. I'm happy with it. I think the Y max can come down a bit. So I'm going to go 15,000 on the Y max instead of 20,000. See, then you get rid of some of that blank space up here. And to be honest, I want to see a bit more in this corner. So I'm going to decrease the X min and the Y min so that I can see more. Y min, I'm going to go negative 200. I base it on what I have for my X max. And the Y min, I'm going to go negative 1,000 maybe. There we go. That's better. You see all the values here. Okay. So let's find the x-intercepts. We're going to go y2 is equal to 0. We're going to go second, trace, and I expect you to show me your keystrokes on your quiz AC, what have you. So let's go ahead and do that. You go to y2, make that 0. Hit graph. There's your red line. Let's find the first one over here. So you go second, trace, intersect, and I want to find this one. So you got to go closer to that one. I'm going to go left arrow. Once you're closer to that one, you can stop and just hit enter 3 times. 1, 2, 3. There it is. It's negative 1.76. negative 1.760. And I'm going to find the second one here. Second trace 5. Now you got to go over to the other side. That is closer now to that other one already. So you can hit enter 3 times. 1, 2, 3. It's a larger value there. 721.12 if you round that. Okay, I've got that. I have a max here. I have the what do we call the vertex, right? Max, which in this case we have a name for it. It's actually called the vertex of the parabola. Guess what we have to press? Second trace max. If you press second trace min, it's going to try to find it, but it will just not find it. It will give you a number. It will be wrong. Okay, so you have a max. It's the highest point right here. Do you remember how to do that one? Let's try it. Second trace maximum. Maybe hear me out because it's been a while. You know the vertex is right here. It's asking you, hey, give me a left boundary. Give me a point to the left of the vertex. You might need to travel to the left of it. Right? Somewhere in there is fine. Anywhere to the left, to be honest. You hit enter. As soon as you do that, it's going to ask you for the right boundary. Give me a point to the right of it. So I'm going to go and travel to the right, hit enter. So now you've told the calculator, hey, the vertex is somewhere between here and here. Go find it. So when it says guess, you just press enter. And there it is. 359.68, 8,752.73. These numbers mean nothing. They have no context right now. We don't know, right? A word problem could be like, oh, this is maybe days and how much money you'll have in your account after that many days, right? That's what's coming down the pipe, but we don't know right now. So let's check. We found our y-intercept, we have our x-intercept, we have our vertex, i.e. max in this case. So now we have everything we need to graph. Okay? So this is probably the most challenging part, is to come up with a good scale. Y, x. Okay, just label that. When it comes to my x values, I'm going to go with the x-intercepts. I need to go all the way to 700, probably 800 on the positive x here. So I'm going to do that. I'm going to make that work. So I'm going to try 200, 400, 600, 800. That will work. So that's what I choose. Okay. And so therefore, you must use the same scale going to the negative x. Right? You have to. You can't choose that. And then for the y, I go as far up as 8,700, right? So I'm going to go to like 9,000 or 10,000 here. So let's see. 2,000, 4,000, 6,000. That doesn't really work. And I don't want to extend it. Let's go up by 3,000. Or can we do 2,500? I think 2,500 will do. 2,500, 5,000, 7,500, 10,000. There we go. So guess what? Your negative values here have to follow the same. It should be negative 2,500 going into the negatives here. And this is called the origin, right? At the center, it's 0, 0. But we don't bother writing that down there. Okay, so now you just plot your points in any order you'd like. So if you want to do your x-intercepts, guess what? That negative 1.76, yes, it is very close to your origin. Very close. We're just going to put it right there. The 721, let me see here. This is 600. Halfway between 6 and 800 is 700 right there. So 720 is just over to the right by a little bit. Make a big point right there. The vertex, 359. So this is 300. This would be 350. 359 is just over here. So I'm going to go up all the way to 8,700. So it's basically, let me see here. What would it be from between here and here? What would it be in here? 17. You add and divide by 2. Did you know that? So if you're ever sure, it's like, what is it halfway between? Go 10,000 plus 7,500. In this case, it should be, oops. Right, and then you divide that by 2. So 8,750 is right in between. Right? So if I match, this is going to be tough. 350, 359. I'm going to go all the way up to here. This is what I mean by when it comes to these big values, you can't be bang on, right? It's impossible. But if you're approximately where it's supposed to, feel like I'm off. Do you see that something is wrong with it? The vertex doesn't seem in the middle, does it? I'm off. I can see it now. Sorry, guys. It's 359. If this is 300, 359 is right about there. 300, 350, 359. So I'm going to go up here and fix it. There we go. That's more like it. Where's my y-intercept? 0.85. So this would be 1250 right here. So 85 is still very close, somewhere in here. That's my y-intercept. So the only thing that you need to watch out when you make your graph, honestly, sometimes they're quite ugly and the province is going to be like, yeah, that's fine. They don't want a V here. They don't want like a sharp V at the vertex. So you kind of want to go out a little bit and then curve in. Just take your time and put an arrowhead to it. Some students find it helpful to go light first. I'm just going to go a light, just going to practice a little bit, and then they commit. And another thing, make sure that your legs, right, they point out. Because if these at all, I'm not kidding you, there were some exemplars that I marked because some students have written like a pilot exam. They went like this. I don't know why, but it just went in a little bit and we had to take off a full mark for that. Because it's like a concept thing, like this keeps on opening indefinitely. But everything else, like some graphs were so wonky, like they were like wobbly, but as long as they kind of look like a parabola and they don't point in, you were all right. Okay, that's our quadrat. Oh, we're missing one thing. Somewhere on here, label your, and I don't know if you noticed, but this equation that I gave you has 3 decimals for the coefficient. That is something you can expect. Don't let that throw you off. You're expected to state in 2 decimals. Sometimes the question will say state to 3 decimals your coefficients. Just go with what the question, but 2 is a standard. I know it's tiring, but you're going to have to practice this, okay? You see with the window that I play with it until I get it. I don't just show you the perfect window because that's not what it is. Like you're going to have to maneuver through this, okay? We're good? Let's do a cubic. That's why I wanted you to watch the first 7 pages and I could just jump right into these ones. Okay. We know that this is a cubic. How do we know that? Well, I see the x to the power of 3 in there. I know that the leading coefficient is negative 4 over 3. This is negative 1.33 repeated, right? It doesn't really matter. But what we know is that the end behavior, I didn't do this with the other ones, but you should probably on your study sheet have something. If this is negative, we're doing this, right? The cubic function is going to do something like this. Imagine a linear would go like this if it had a negative slope, right? The cubic follows the same behavior. So it's from quadrant 2 to quadrant 4. We know that. We're expecting that. Is there anything else that I know right off the bat? If I look at this, but that one right there, y-intercept. Y-intercept. You know what? I call everything in between blah, 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 right? Like it's leading coefficient. And then the last one, everything in between is whatever, right? It does affect it, but we don't know exactly. So we just kind of focus on those things. Okay, so let's enter that into our calculator. Can you do that, please? Okay. Do you notice what is missing when you look at your equation? There's an x cubed, there's an x squared, there's no x term, correct? It doesn't matter. It's still a cubic. The cube, the highest power determines the behavior. Everything else is kind of like bonus, right? Okay, let's try to graph this thing. Hit graph. Hey, we see something. That looks like a parabola, doesn't it? But it's definitely not a parabola, right? We know that. Okay, so let's try zoom fit. Let's throw a fit. Did I enter it wrong? Okay. Shame on me. You see it? Shame on me. But it definitely is a parabola because I've got an x squared here. Okay, my bad, sorry. So to the power of 3, you just got to use that hat, right? Bring it back down. How can you do insert? Anybody? Okay, there we go. Second delete. And then I got to go plus, right? Plus, second delete. No, second delete again. Second delete, insert. Hey, then it inserts. Thank you. Do I have that right? Okay, let's try again. I'm going to go zoom fit again because obviously mine was. Okay, zoom fit isn't really doing its job here. I'm going to try one more time. Yeah, no. But what do we know about this? We know that it's doing this, right? We know it. So what are we going to do to make this change? I'm going to definitely start by increasing my Y max. So let's go to our window. And I'm going to increase my Y max here. Ooh, it's already big. What happened here? I feel like zoom fit is not a good, it's not doing a very good job here. Let's try zoom standard. Zoom standard. There I see a bit more. Okay. Let's increase our Y max. I'm going to go 50. because I'm assuming that this is what's happening. It's coming from here, it's dipping down, going back up, but it will eventually turn back here. So I'm going to keep increasing my Y max until I see something. I'm going to go Y max is 150. I'm going to keep going. 350 for the Y max. There we go. Okay, so now I saw it doing this. Now I'm just going to have to try, I'm going to decrease my Y min as well. So Y min, I'm going to go negative 150. I'm just going to go quite a ways down for my Y min and try it again. There we go. And I now have to increase my X max a little bit. I'm just going to increase that value. X max, I'm going to go 50. So there we go. Zoom fit doesn't always do it for you. So now I see it. If you want to look at my window real quick, look at it there and type in those values. But it doesn't matter if you have the exact same values as me. As long as you see it, you're good to go, right? Okay, hit graph. You should see this. We're going to find our x-intercepts. y2 is equal to 0, second, trace, intersection. How many x-intercepts do we have? 3, right? There you go. Let's go find them. Second trace, 5. I like what's happening right now. I do not see my cursor. But I look at this value here. So I'm going to go left arrow. And as I go left arrow, this is coming closer up to me. There it is. And so I'm going to hit enter 3 times. And it's going to find that one, which is 11.13.0. Let's go find this one here. Second trace 5. Let's travel left. Enter, enter, enter. That is 1.220. And let's find the one that's really close to it. So I have to go, I would go past like this so that you make sure you find that first one, and that one is negative 1.10. So there I have my 3 x-intercepts. Perfect. Now I'm going to find, this is where I go local min, and local max. Local, like this, technically this doesn't have a universal max, right? Because it keeps going up indefinitely, but it has a local max and a local minimum. We focus on those. So to get the min, guess what? Second trace min. And to get the max, second trace max. So we're going to find those 2 points. They're very important to us. So second trace minimum, go to the left of it, because it says for left boundary. If this is where it is, you go to the left, hit enter, and you go past it to the right, hit enter, and then enter one more time. What is this value right here, folks? You remember? When it's e to the negative 7, it's times 10 to the power, right? Times 10 to the negative 7. So this is actually 0. Okay? So this is 0, negative 20. And the local max, second trace max, you go to the left of that one, which you are right now, hit enter. Then you go to the right of that, hit enter, enter one more time. 7.50, 261.25. So there you have the local max and the local min. And now you're ready to graph this thing, believe it or not. Okay, let's do it. There's nothing to it, guys. Just gotta practice this, that's all. So for my scale, 261 is like the furthest right I go in my x-axis. Right? So I got to make sure I include that. So 100, 200, 300. That's what I'm going to do here. And here I'm going to go negative 100, negative 200, right? So I'm keeping the 100 scale for every 5 boxes, I go 100. So it means that every box is worth 20, correct? So for my Y, I gotta go as far up as, oh, sorry guys. You see my mistake? Why did I go 260? This is my Y, correct? The furthest right I need to go is 11, 13, right? When I look at all my X values, so sorry, I have to redo this. My bad, sorry guys. Could have been worse. I could have had done the whole question and then found out that I didn't meet that scale, right? So I'm going to go 5, 10, 15. That works just nice. Okay, now with my Y, yes, the highest I go is 261.25. So here I got to go up by 100. 100, 200, 300. And then we're going to go same thing, negative 100, negative 200. Here, we've established our scale just like that. Mr. Erickson, you're doing a 5 here and a 100 here. Can you do that? Yes, you can. Okay, but within the axes, it has to be consistent. From left to right, same here, it has to be consistent. So let's plot what we know. The y-intercept is 0, negative 20. Guess what? I told you that this is actually going by 20 here. So negative 20 is right there for me. You notice something? My y-intercept and my local min is the same. Don't panic when you see that. It just happens to be the case. It's like a 2 and 1. The y-intercept is also the lowest point. Okay? And I'm going to plot all my x-intercepts. The first one is at negative 1.10. So this will be right there. Negative 1.10 is right there. Then there's positive 1.22, which is right there. And the next one happens at 11.13. So right there. So I've got my y-intercept, my x-intercepts. Now I'm going to do my local min and my local max. Local min is already taken care of. Local max is 750. So 750 would be right between 5 and 10 right here. And then go up. This is 100, 200. This would be 250. 260 is actually right there. 261 is just above it. That's okay. Close enough. So here we have it. You ready? Maybe I'll start here. I'll just do this part first. Just curve it, curve it. There we go. That's one. And I'm just going to finish off this one here. Don't go too far. Just put an arrowhead and then you're good to go. Isn't that beautiful? That's like art. Yeah, right. Yeah, right. You've got a bad taste. There's your cubic function. Was there some playing around? Yes, there was. Absolutely. Could you have picked a different scale? Absolutely. You're not going to be marked wrong. Your graph may look a little bit more squished or smaller because your scale is different, but that doesn't affect the value of it. It's almost like looking at the same picture, but someone has took that picture from way back there, like at the end of the soccer field, and somebody was standing right in front of you to take that picture. It's going to look different, but it's still the same person or object on that person, on that picture. Okay. This is, now we're handed off to you. I'm just going to say, first of all, homework. I have a bunch. So this goes from 11 all the way to 16. But I'm going to circle the ones that I would, oops, sorry, you can't see that. Graph, okay? I need you to be able to graph these things. I need you to be able to struggle and find your window. However, whatever you must do, find your window. But please don't do it blindly. Do what you know the end behavior, right? If this had been positive, if the leading coefficient had been positive, I would expect it to start somewhere here and move over to there, right? So I would have expected a different behavior. So let's go circle the ones I really want you to practice. So I basically will ask you to do one of each minimum. Okay? Come with me. I'll say that on page 11, circle question 2 on page 11. I want you to do that one. Don't worry about the domain that it says there. Don't worry about that. Just make sure the intercepts are on there and you're good to go. Then I'm going to ask you to go to page 13. I'm going to ask you to do question 2 on page 13, right? And I will give you one that's going to give you a hard time with your window. 14 question 4. That one is going to give you a hard time when it comes to window. And I'm telling you already, it doesn't seem to have x-intercepts as far as I can picture it. It's okay. You just find the points that you can and make the best of it, right? Your y-intercept, your vertex, find the other ones. Then go to 15. That's when the cubic functions start. Let's go question 6 on page 15. Circle that one. And on page 16, question 8. That's a cubic that's pointing up. So if you're able to graph those, you're going to be in okay shape. Okay. I think I'm going to stop there for today. If you want to get started, maybe start on the quadratic or a cubic, and then I will post the key. And that's it for today, guys. It's all about graphing. Thank you.